Learning blockchain can certainly be challenging. There's a lot of terminology to learn, there's a lot of concepts to digest. In this session, we're going to do a visual walkthrough that should be pretty accessible. And we'll start off with the concept of a hash, which is core to blockchain. A hash is simply a digital fingerprint for some data that you enter. In this case, I'm going to enter the word hello here, and you'll see that below it in the field denoted by hash, we have a long string, and below that is an identicon. This is the hash that was generated. The identicon is trying to create a visual anchor for that string. Something else to note is that it doesn't matter how much or how little text I entered, the hash is always the same length. In fact, even if I enter no text at all, we get the same length of hash. The other thing as well is that it is deterministic. Given the same input, we get the same hash. So if we enter the word hello here, you can see that the hash starts with 2CF. We get the identicon. If we remove it and we type hello again, we get 2CF once more. The other thing as well is that it doesn't matter how much text we enter. I'm going to enter here a long block of text in Latin, and you'll see here the identicon and that the hash string starts with 274. If we remove it and paste it in once again, you'll see that we once again get the same hash. So just to emphasize once again, it is deterministic. The other point to note as well is that you cannot guess the input from the hash. Some people like to compare it to baking a cake. Once you mix the ingredients, you bake the cake, you can no longer go back to the input. So in this case, the hash you cannot guess the original content from the hash. So with that in mind, let's go ahead and extend the concept of a hash to a block. I'm going to go ahead and navigate here to the block exercise. And as you can see there, I have something very similar to what we had with the hash, except that we have some more fields. I have a block, which will be the number of the block. I have a nonce. We'll come back to that in a minute. Then I had the data block or box, and then I have the hash. Now, there's something else that I'd like to note about this hash. It starts with 4 zeros. And as you can imagine, that is something pretty unique. And just by the convention of this exercise, I have decided that a hash that starts with 4 zeros is a valid block. So if I enter some text in the data field, most likely I will not get a hash with 4 zeros, which would mean this will be an invalid block and the color will change. Once again, this is simply by the convention of this exercise that we have decided that a hash that starts with 4 zeros makes it a valid block. And so as you can see here, this is invalid. And so what we'd like to do is we'd like to make this a valid block. And this is what we use the nonce for. And we can start to explore the nonce space here. I'll enter 1. That didn't work. A 2, a 3, a 4, a 5, a 6, a 7. And you can see there that that one started with 1 0, but we need 4 zeros. And so you can imagine that I could spend here a very, very long time trying out numbers before I found something that had 4 leading zeros. So this is what this little mime button is for. It's going to explore the space programmatically. And I'm going to go ahead and click that now. As you can see there, it found a number that made the hash valid. And that number was 59,396. So that is what a block is. Let's go ahead and move to a chain of blocks, a blockchain. And as you can see here, I have 5 blocks. Block 1, 2, 3, 4, 5. I have the same data fields as before, block and nonce data. And I have an additional field, previous, and the same one that I had before, hash. So if we go back, if we go all the way to the end to the 5th block, and we look at the previous, you'll note that the hash of block 4 is the previous on block 5. Just as well on block 3, you'll see that the hash for block 3 is the previous on block 4. And all the way back to the beginning, and at the very first block, the previous is all zeros, simply noting that this is the first block, often called the genesis block. So with that in mind, let's go ahead and look at the end of the chain here, and let's go ahead and enter some data. And just as before, we've invalidated, we've broken the block, it's no longer valid. And if we remove it, then we go back to a valid state. Now, if we do the same on block 4, what do you think will happen? Certainly, it will invalidate this block. But as you've noticed, it has also invalidated block 5. And the reason for that is because the hash has changed, and the addition invalidated the hash for block 5. That is, it doesn't start with 4 zeros anymore. So we can go ahead and mine block 4, and you can see there that's now a valid block. But block 5 continues to be invalid because although it still starts with 4 zeros, just as before, the rest of that hash is different than the one that was there before. And so this block itself would have to be remined in order for it to be valid. Now, if I were to make a change on block 5, let's say here, hello, and I mine this one, you can see that pretty quickly there we find a success. However, if I went back to block 2 and I typed hello here, you'll see that I have invalidated the rest of the block, and I'd have to mine this block, then go to block 3 and mine that block, and then go to block 4 and mine that block, and so on all the way to the end. Now, as you might imagine, the puzzle that we're solving here, the leading 4 zeros, is a pretty easy hash to match given the computational power of a machine. However, the puzzle that's being solved on the open blockchain is much harder. It takes the entire network to be able to solve it. And so to be able to mine a single block, it's a considerable amount of effort, and every additional block is that much harder. And so as time goes on, the robustness of the data increases. And this is one of the properties that is often called out. Now, I've left out some of the details. The data field, of course, is richer. It carries with it transactional data, but the core workings of the blockchain are very much what we just walked through. There's a block, there's hashing, there's a connection between the blocks, and this is at its core the mechanism of blockchain. There's just one additional important concept that we did not cover, and that's the consensus mechanism for the entire blockchain. But there's a great deal of consensus mechanisms to choose from, and we'll cover that separately.